Welcome to part 2 of my large 3D printer build. It started out with this frame, but I've changed a lot of details on this printer and made some major changes as well. Please check out the video part 1, and please note I'm not trying to build the best possible printer or something designed for industrial use. This is just for my hobbyist use. And I wanted to go big and cheap. This is where we left the build in part 1. This is what the completed printer looks like, and in this video I'm going to look closer at some details, the configurations and some prints. I hope you'll find that interesting. We'll start out looking at the external components of the printer. The build plate is 300 by 900 by 240. And the usable length in Y is actually 820. I made this frame a little bit too small. It should have been 10 centimeters longer in the Y direction. In my build, this is the side of the printer with 2 temperature controlled fans. In the front I have a couple of thermostats not being used, a standard display, and a thermostat for controlling the internal fan under the covers. And this is the caddy for the electronics, the SKR 1.4. On the other side of the printer you'll find the power inlets. One is just for heatbed number 3 and the other one is for the rest of the printer. To the rear I have an enclosure for the SKR Pico that will serve the X and Y axis and the first heatbed. The tool head is a plain Stealthburner. Only change on this one is that it's using one belt on the mount. I'm getting a lot of really useful comments to my build videos, and one thing people didn't like about this first part was this one. They wanted me to use a thrust bearing, and I completely agree. I ordered some of these and made a small adapter for it. That would make it easy to use this thrust bearing on my existing motor mounts. All I had to do was to pop them in and then add the bearing and then the coupler onto that again. It didn't take more than probably 15 minutes to do this on all 4 stepper motors, so that was worthwhile. Thank you for the suggestion. When looking at the kinematics of this printer, it's a standard Cartesian printer. I considered doing Core XY, but the long belts prevented me from going in that direction. And I think this is a safe choice and it wasn't too difficult to build. I was happy with the Remix beefy idlers I showed in part 1 of this build series. They seem to work quite nicely with the 9mm belts on the Y. I have kept the X idler unchanged. I think this is pretty good. I made some changes to get this cable chain to work and to get the cable not to interfere with the sides of the printer. This is the movement and the Y attach point for the belt. And the Y motor mount with double shear. This is the custom part I like the least. I'm probably going to change this quite soon. It will have to do for now. The rear mounts are much better and I'm going to keep these as is. One clear advantage of building a large printer like this is that there's a lot of space. No problem with wiring. This is the Pico and I'm also using D-subs to connect the thermistors from the heatbed. I'm using a SKR 1.4 turbo and a Radxa Rock 3C, and I made a special mount for the fan. I'm using 2209 steppers on the SKR 1.4 and I had this really annoying problem. The jumper settings doesn't work with this Phi-Setch or Phi-Sect or whatever you call these steppers. I had the same problem years ago but have forgotten all about it. Thankfully we have the internet, or rather search functions. I have some cheap thermostats in this build. I'm using just one of them, As you can see on the thermostat, it's pretty cold in my climate, just 19.2 degrees under the cover of the printer. I spent way too much time on this enclosure for the Pico, designing it and finding the right location. I decided to install it midpoint so I could avoid having a cable chain to the tool head. I still needed a cable chain for the X motor though. I think the final result looks nice. And this is the cable management for it. Most of the time I use the web interface for controlling my printers, but it's nice to have a local display as well, especially for filament unloading and loading. And this doesn't cost much either. In my first build I wanted to try out just using a couple of Picos, but the Pico doesn't have a display output that is compatible with this. So that's why I have the SKR 1.4. The reasoning behind using two different controller cards in this build is to keep the cost down and simplify the wiring. But how do you do that in Klipper? It's actually easier than you might think. All you have to do is to define the second MCU and give it a new name, like in this case MCU XY. And then you use that prefix for all pins that should be used from that controller board. So this is pretty simple. Pins using the main control board, then you just drop the prefix. But what about multiple heat beds or heat zones? Well, Klipper's got you covered. All you have to do is define some extra heaters and give them a name, like heater bed 2 and heater bed 3 in my case. You can then edit your start print macro and adding these two extra heat beds or zones. They'll pick up any variables sent from the slicer and set the target. Please keep in mind that you have to do the same thing with the end print as well, so you switch off the heated beds. You can of course also automate what bed is heated based on the size of the print. This is one way of sending the temperatures from the slicer. This is from Orca Slicer. As you can see, I've added the bed temp 2 and bed temp 3 variables. This is what main sail web interface looks like with the extra heater beds defined in Klipper. Let's test some movement. I'm doing this in real time, first with the homing and then the Z tilt. If this is not your thing, I certainly understand that and you can skip ahead to the next timestamp. This is homing and the max on this printer is in the front of the printer. And the homing completes. And it's starting on the Z tilt procedure, and it's actually using 4 points for the Z tilt. I guess you could use quad gantry leveling, but it says in the documentation that's not recommended for a moving bed. I'm not quite sure what the difference is between a 4-point Z tilt and the quad gantry leveling, but this is what I'm trying out. It will then do the last probing point and repeat this cycle several times until it gets within the parameters that was set for this procedure. The next step is creating a bed mesh, and that takes forever on a large printer like this. An inductive probe really isn't what you should use on this size of a printer. It would be better to use a Eddy or a Carto, and I will get that later for this printer. And I'm not going to show this complete procedure, it takes far too long. This is the first print ever made on this printer. The acceleration settings were far too high and the result wasn't that great, but it did print. The next print I tried out was to print the part for my Voronish 1. I'm building an enclosure for it and need some parts that are longer than I can print on the Voronish 1 or 2. This printer's got a 0.8 nozzle and that seems to work fine. I tried printing some PETG as well. Those lines are pretty fat with a 0.8 nozzle. This is the part fitted onto the top of the front door on the Voronish 1. This printer is far from a Voron, but I still wanted to print a Voron cube. And with the dialed back acceleration and speeds, the results became a lot better. And this is still a 0.8 nozzle and 0.4 layer height. That's not too bad, but what about larger prints? This is, after all, a large printer. That will have to be for the next video. Large prints will take days, and I can't do that just now, but I will get back to that shortly. I'll also spend some time figuring out what I can do with this heat bed. These are 3 heat beds in a row, and you can see that in this bed mesh. It's 0.675 between the highest and the lowest point of this, and I can improve that a bit more than this. And I really need a larger flex plate. I hope you found some of this useful, or at least partly entertaining. Bye for now.